Hello YouTubers and Bedini followers. So what we have, you're actually looking at the end of charging procedure number 13. Let me quick show you the values of my batteries. So on this side you have the voltage of my primary battery. It's 1184, so pretty good solid voltage level even when my charging procedure is done. So it's actually a good sign that I am not using a full capacity of my primary charging battery. But anyway, look at the values here. Let me this is good. 12.59. So I should repeat once again, I did charge my battery by using low current and radiant impulses, and major energy came from these radiant type impulses. These impulses you can view on my previous videos, where I actually showed these impulses on my oscilloscope. But anyway, this is a pretty amazing result. On primary I have still 11.84 and on my charging battery I have 12.59. So you see, one battery discharged but not to the full capacity, because I can actually run this system to 11 volt with no problem, but I don't want to. I actually want to just to disconnect the battery, the charged battery, and do the discharge procedure and then hook up the battery once again, because I have not so much time currently. But anyway, 12.59, this is real result. And if you not trust me, let me just disconnect one of the connections to the battery from the ECG circuit. And you see the battery voltage decreasing. This is a normal behavior of the battery when it's charged fully. Its voltage is not, how I will say, the voltage decreasing always when the battery is charged, but this is actually normal state. Once again I hook up the ECG circuit and we see how the battery charged once again. So it's charged 12.57. Maybe I actually hold the camera a little bit longer than I want to, just to let you know that I'm actually charging this battery by the impulses which I produce with my ECG circuit. I have the current, but the current is actually not enough to charge the battery when you compare this current, like 28 milliamps, which I use to run the system. And on the other side, on the side where I'm charging, I'm getting even less current. So question stays, how I charge my battery? And the only suitable answer for this I have following. I charge my battery using radiant impulses, which are produced by my circuitry and the coil which I use. And this is a standard Bedini schoolgirl system. This is not an over unity system. Why it's not over unity system? Because for the primary battery, this is actually, let me zoom out, this is actually this battery. I can maybe, okay, some actually, this is some advertisement for this manufacturer of the battery. But anyway, this is 12 volt 5 hour battery. So back again to the side where I'm charging the battery, and you see the voltage 12.59. Well, let's hope it will reach 12.60. But anyway, I shall say approximately 24-hour charging time, and pretty good because my primary battery doesn't not discharge a lot, and I have here high voltage on the side where I'm charging my battery, so pretty good. And this is even better than my last result. But as BDini told, do not, when you do this charging and discharging procedures, do not charge the battery with a conventional charger device. I mean this battery which I'm actually charging right now. If you want to do the experiment, charge conventionally only one battery, and this is battery which I mean is primary battery. This battery should be charged always conventionally at 20-hour charging rate. And funny thing, I do not use charging device, conventional charging device with an automated system where it controls the voltage level. So sometimes I overboil my primary battery, and maybe it depends too of the quality of the charge. But anyway, you see real 20.59 volts which I got on my system. Pretty good result, I will say, for this amount of time and energy. And yeah, if you wish now to look at the side where I have my primary battery, 11.84, and this is a result of my charging procedure number 13, and I saw some great results after I charged and discharged the battery 11 times. Okay, now you see it's going to 20.60 volts. Okay, let's look how it changed to this level voltage. It's not rapid voltage increase, rapid voltage charging, but it's steady voltage anyway. And the result which I am showing you is a pretty amazing result, because my primary battery does not discharge it completely, so I'm starting to get more energy and put less energy, or put enough energy to charge the charging battery. You can decide yourself. I can only say following. In any charging procedure, my primary battery always charged conventionally, always charged to 20-hour charge rate. Normally I use like 300 milliamps to charge my primary battery. So still it's a research procedure, research experiments, and I cannot you advise to use the system for the practical way. But yeah, I should mention BDini itself, when you think about his commercial products, which he of course offers, they are using some this type of energy which I am using, but they are doing the transformation with a capacitor, because they experience a problem when people try to mix up energy. And what I mean, you can actually charge this battery with a conventional charging device, but at some point you will lose the capacity of the battery. So stick to one or other type of the energy. And BDini is told to people that his first line of commercial, first generation of his products used the radiant type of energy, but nowadays they are actually using the standard type of energy, but with a better control. And that means that they know how actually to charge the battery to the full capacity without damaging the battery. Because when you use a conventional charging device with control system, It means it controls the voltage level of the charged battery. So it means that each time when you charge the battery conventionally, you actually decreasing the capacity of the battery, because it does not go to the highest level when you charge the battery. And yeah, just some advertisement for Bedini charging device, because they are pretty cool devices. I mean, when somebody needs a practical device for charging batteries, they are probably will be happy with using Bedini charging device. And yeah, so you see this voltage rate currently at 12.60. I can hold my camera even more time and speak something about what you really should think about. I'm saying once again, I do not use a conventional energy type in this circuitry. My current is too low to charge this battery to this voltage. It's like 15 milliamps or 14 milliamperes, and you see the battery is completely charged to 12.60, and I can once again remove one of the connections from the battery and show you how low voltage drop. The voltage is dropping. This is normal behavior of any battery when it's charged, but you see the voltage is dropping like this. Let me drop it a little bit less than I want to, like to 14, and you see this lamp is pretty. This is actually sound which you are hearing from this lamp. Okay, it's enough. Then back again. Once back again, voltage increase immediately happens, and this is a real normal battery behavior. But what me really confusing is this is actual good result. That what I want to say is that my primary battery does not discharge to full capacity. My primary battery holds the voltage at 11.84, and this is a sign that I'm actually use less energy and gain more energy. But I have my costs anyway, and I have pointed out many times, when you think about capacitor system discharge, capacitor, in my view and opinion, can be used too, but when you use a capacitor system, you need to control the level voltage in capacitor and the discharge it, and the times how often this capacitor should be discharged, because the capacitor have the maximum voltage border, and when you overcharge your capacitor, it can explode, and it's pretty mess if you not control your capacitor charging levels. So people who are using capacitors, they're actually more knowing. They are actually pretty good professionals in this type of the systems, because they are developed some tricky circuitry to just give enough energy out. But I ask myself how good the capacitor should be, and I mean, the battery can only take as much energy as you can give, but you should take notice the battery cannot take a lot energy at some point. So problem with the capacitor arise, and the question arise, battery need some current when you charge it conventionally, and when you charge your capacitor not conventionally, that means then you charge it your capacitor. I'm babbling, sorry. If you charge it your capacitor to 200 volts, okay, and you know how much rate and how and you know the voltage and the current which should go to the battery at maximum. Battery cannot sustain voltage level if the battery using in short time a lot of energy. So problem arise, you just losing the energy when you discharge your capacitor not right. And I mean not right if you discharge your capacitor not at the current which the battery approves. When you discharge your capacitor with a high current, with a high voltage peaks, then the battery probably would not work along. The battery wouldn't work for you for the long period. And for me it's just questions, theoretical questions, how much energy I lose when I do the capacitor thing, because with the radiant impulses I'm pretty sure that I'm very efficient. I'm probably over efficient when I use radiant type of charging. And of course I must say it depends a lot of times on the quality of the battery plates. The battery which I currently use, this battery are allowing to fill the water, distilled water in the battery. You see this caps, plastic caps on the battery. So this battery actually allows you to put water to control the liquid, distilled water liquid in the battery. It's not transparent case in the battery, but I can with a light, pretty high resolution light, I can go through this battery and see the liquid level, because you need to control the liquid level. At some point battery just vaporized the liquid due to the chemical reactions in the battery. But this type of charging actually does not push the battery to this vaporizing of the liquid. So you see, once again 12.16, I prove my point. Battery is actually charging. I can probably bring this charge to even higher charge voltage level, but currently I do not wish this. I'm pretty confident about the thing that I've reached the point where I'm actually getting more energy, more capacity from this charging battery than I did earlier. And you must understand, this type of charging you won't get at the first time. You need at least 11 real good charging and discharging procedures. After that you can get some results. But anyway, I want to go to the capacitor dilemma. Capacitor for me is at some ideas it's a very good system, because when I charge the capacitor and know how I discharge the capacitor, and what I mean by that, I mean I do not wish to discharge the capacitor I do not wish to use the full capacity of the capacitor to discharge it. I wish to discharge the capacitor like, I don't know, in steps. And probably it was showed by the Bedini at the conference at some point, that he showed this steps charging process, and capacitor was involved. But anyway, you cannot mix this energy. This is a very important thing. If you charge with this type of the energy which I actually get, you cannot charge this battery conventionally. But who cares? I mean, you can use this energy with the conventional systems. You can hook up inverter, you can hook up your lights, you can hook up any device. But what you always should think about, you should always think about that your load and the level of the current doesn't discharge the battery below the 11 volts. If you do this, you damage your battery. I done such experiments in the past, and I know that it is not working. So do not do this. Just just control the voltage level to 11.60, 11.70. I know it's not always easy to get your 20-hour discharge. In my previous experiments, I'm not at the point to say that I can discharge this battery at 20-hour discharge rate, but I'm pretty sure I'm going to this point when I actually can discharge the battery to that level which I'm into. But you see, battery stabilize at 12.60. I hope it can go higher. And okay, I have movement of the wheel. I have voltage meter here, 11.84, primary battery voltage level. And you see, this is actually running the system, and the movement of the wheel is not high. I told in my past previous video that you actually can put the fan on the axis and run some type of wind turbine from your wheel, and it's crazy idea, I know. But anyway, what important about Bedini things, it's a battery quality and the discharge procedure quality. When you do this right, you can even achieve better results than I, because what I'm actually thinking about that my coil working in the, I would say, you have two different modes, two different types of winding the coil. One time is a clockwise and another time is a counterclockwise. If you wind your coil counterclockwise, you actually produce a force which actually better runs the system, run your wheel. I forget this word for the magnets. When you have south pole and north pole, you have a traction force. Okay, I know what I'm speaking about. My system, my wheel does not work in a traction type. It's a repelling force, because I'm producing with my coil north pole, and the north pole is on the magnets pointing always to the point to the coil, and I have repelling force and repels the wheel. But anyway, I thinking about that I actually got a successful charging procedure. What I shall tell you about. Yeah. You see the amounts of, oops, out of zoom. Sorry guys, sometimes it happens. Okay, now it's stabilized. You see this amount of cables. I'm thinking about when I build my next system, I will minimize to the minimum the amount of the cables, because when I use cables, it's actually not very efficient way to build the system, because each cable have own resistance and blah blah blah, and it can lower your efficiency a little bit. Not huge, a little, not very. It's not very influential on your system when it's actually running at this type of settings which I have, but it's enough to give you idea that you can actually build better systems than this. And what I want to tell you, you see it's stabilized at 12.60, and at this point I think this is enough information for you. Just think that it's possible to charge with the impulses which I produce in my system, and I wish you all the best. For me, it's successful research, successful charging procedure, and until the next, I will show you another seven charging procedures, and then probably when I have time, I will start to use the energy of the primary battery, and I mean I will try to use actually not the primary battery, actually the charging battery. I have a inverter, and I have conventional charging device, very primitive, but what I'm actually trying to say you, at the end of my currently running experiment, I will start another series of the charging and discharging procedures, but it will be different experiment, because this time the charging battery will be used as a primary source to charge the primary battery. And of course it will happen always separately, but what is actually will be different, I will not pay the energy company to charge my primary battery. So this should be the conclusion of research, of the public research, and start of some probably closed research. But anyway, I want to share you this information and to tell you that it's possible to use radiant type energy in practical and very efficient way. So thank you all, and bye bye.